Enterprise AI projects are remarkably similar to New Year's resolutions. In January, everyone is highly motivated, launching pilots and running demos. But fast forward a few months, and most of those ambitious ideas have been abandoned, leaving behind a landscape of inactive servers and dead code. This chart shows exactly how steep that drop-off is. 75% of these initiatives fail to deliver their expected return on investment. And of the few that survive, a near 16% actually manage to scale across an entire enterprise. A major driver of this collapse is a phenomenon called AI technical debt. When teams operate with a ready, fire, aim mentality, rushing to launch a model just to prove they can, they are essentially taking out a loan against their future stability. In practice, that debt looks like brittle, hard-coded prompts, zero performance evaluation, and security measures tacked on as an afterthought. You end up with a pilot program that works perfectly on a laptop, but instantly breaks when exposed to real users. These systems don't fail by accident. To survive the jump from a controlled pilot to actual production, we have to look at the root causes of these failures and adjust how we approach machine learning. If we perform an autopsy on those failed projects, a clear pattern emerges. The first major error is starting with the technology instead of the actual business problem. Asking, how can we use AI, leads to aimless experimentation. Artificial intelligence is simply a tool. If a project isn't anchored to a specific, measurable metric, like reducing customer wait times or lowering operational costs, teams end up building in the dark. The second trap is treating machine learning as an isolated IT project. Deploying these models touches existing processes, alters employee roles, and shifts product development. That means you need active stakeholder buy-in from day one. If a sales director or compliance officer doesn't understand how the model helps their specific workflow, they will view it as a risk. Instead of championing the new system, they become active blockers to its adoption. You can have the most elegant algorithm in the world, but without human alignment and a clear mandate, it will stall. Even with the right strategy and a supportive team, projects still die if they ignore the third critical step, planning for deployment from the very beginning. Building a model in a controlled sandbox is safe. The data is clean, variables are known. But deploying that same model into a live production ecosystem is chaotic. In the rush to launch, teams often fail to account for how legacy systems will integrate with the new code, or how they will monitor the model for performance drift as new, messy data streams in. Knowing the strategy isn't enough to survive. Organizations need a robust underlying infrastructure designed to handle the intense pressure and security demands of enterprise data. This shows Treecapital's flagship model, Anven AI. It functions as a sovereign intelligence layer, providing the architecture to prevent technical debt. Sovereign AI means intelligence lives within your control. Anven operates behind a corporate firewall, ensuring absolute data ownership and zero exfiltration. For highly regulated sectors like healthcare and finance, sending sensitive information to public APIs is a deal breaker. This private cloud architecture allows processing data locally, maintaining compliance with mandates like HIPAA and GDPR. It also addresses the risk of false outputs. Anven uses a framework called strict grounding, natively integrating retrieval-augmented generation. The model is forced to cross-reference answers against your verified internal databases. If the data doesn't exist, it reports the absence rather than making something up. By anchoring the system to facts and securing the infrastructure, Anven turns generative AI from an unpredictable liability into a reliable, deterministic asset. This level of control provides a direct solution to the deployment trap we saw earlier, especially for physical industries like telecommunications, automotive, and manufacturing. This illustrates Anven's edge-native architecture. Using optimized 3 billion parameter models, the system scales down to run directly on physical edge hardware. This allows phones, wearables, and embedded hardware to execute complex reasoning with near-zero latency without relying on a constant internet connection. Escaping the AI graveyard isn't about chasing the newest algorithm or rushing out a flashy demo. It requires a disciplined business strategy paired with an infrastructure built for real-world deployment. True enterprise success comes from transforming your proprietary data into a lasting competitive advantage. It's time to stop renting intelligence and start owning it.